Welcome to InsectTech's Ethical Hacking course videos, module Cryptography. In this video, we'll see the introduction and history of cryptography, and various basics of cryptography and digital signatures, and finally hashing and few demonstrations on cryptography and hashing techniques. To start with, let us consider a scenario where I want to send information in a format that a normal user cannot understand even if he reads the information I am sending. And in another scenario, I am receiving some information from a sender and I want to verify the identity of the sender. And these are the two typical scenarios where I need cryptography. And we have many other scenarios. These are just sample examples of where we need cryptography. And the definition is, cryptography is the practice and study of techniques for secure communication in the presence of third parties. It's all about when two parties are communicating with each other in the presence of a third party, how securely they communicate so that the third party cannot see their communication. And basically, cryptography typically can be divided into algorithms and protocols. Algorithms are the procedures that take inputs such as plain text and process it and finally produce the output, that is ciphertext. And protocol is a set of rules by which two parties can securely communicate among hostile eavesdroppers. And this is the basic terminology that we have to know before actually getting into the cryptography techniques. Plain text, a message in readable or comprehensible form. And ciphertext is after converting into some unreadable format, we'll get this ciphertext, a message in an incomprehensible form. Encryption, converting the message from plain text to ciphertext is called encryption, and getting back the plain text from ciphertext can be called as decryption. And secret key is the knowledge to decrypt the message from ciphertext to plain text, or else to encrypt the message from plain text to ciphertext we need to have a secret knowledge, that is key, and the key is only known to the communicating parties. And finally, cryptanalysis, to find some weakness or insecurity in cryptographic scheme, and we call that process as cryptanalysis. And coming to the history of cryptography, before the modern era, confidentiality was concerned solely with cryptography was concerned solely with message confidentiality. Means we encrypt the message using a key and send it to the destination. And now if an attacker gets the encrypted message, he should not be able to decrypt it without the key used to encrypt the message. And before modern era, this is the only target of cryptography. But in the modern era, cryptography has been expanded beyond confidentiality by including authentication, integrity, and digital signatures, and many more. Authentication, senders or receivers authentication. Integrity, the message which we are sending should not be changed before actually reaching the destination. Digital signatures, to identify, to verify the identity of the sender. And these are the types of encryption we have. One is symmetric key encryption. In symmetric key encryption, both parties share what is known as a secret key. They use the same key for encryption and decryption. And asymmetric key encryption, this is also called public key cryptography. It uses different keys for encryption and decryption. And we call this symmetric key, we call it symmetric since both the parties use the same key. We can see that in the figure. We have plain text and we are encrypting the plain text using some key K, and we are generating the ciphertext and we're actually sending into the destination, and the destination party, in order to see the plain text, he has to use the same key, and this is symmetric key encryption. The goal of ciphertext here is to make sure that an eavesdropper cannot read the plain text of a transmission from sender to receiver, and an attacker can capture the ciphertext here, can read it all along the day. Since he has no key, it will mean nothing to the attacker. Now when the receiver receives the ciphertext, he combines it with his copy of secret key using the proper decryption algorithm. This produces the original plain text that the sender has encrypted for the receiver, and this is symmetric key encryption. And coming to asymmetric key encryption, this is very similar to symmetric key encryption, whereas the keys that are being used are different for encryption and decryption as well. Means the sender encrypts the plain text using some key K1, and he sends the ciphertext to the destination, and the destination, in order to decrypt the message, he uses some other key. This some other key is, this key K1 is receiver's public key. The person who is receiving will actually decrypt the message using his own private key. This is very similar to our email processing, where we use the receiver's email ID, which is known to everyone, which is public, and he will read the mails using his own private key, which is his password, which is known to only the receiver. And this is how asymmetric key encryption works. Now let us try to understand what are digital signatures. Public key cryptography can also be used to digitally sign and verify the data. The purpose of signature is to prove that the document was created by or agreed upon by the signer. And the process in digital signatures is very straightforward. It is done by encrypting the data with the signer's private key, and at the receiver side, to verify the signature and decrypt the document, they need only to decrypt it using the signer's public key. And it also gives a data property called non-repudiation. It means the data cannot be forged by someone. And this is how digital signature works. This is a pictorial representation of digital signature, where we have a original document, and the sender is signing it with the sender's private key, and he is sending the signed document, and after that the receiver will receive it and he will try to decrypt it using the sender's public key. This is how digital signature works. Let us now try to understand how we can use cryptography in a real world using a small demonstration with a tool called TrueCrypt. I'm just going to show a small demo with a tool called TrueCrypt, which is very nice tool. I have opened the interface. I have already installed this TrueCrypt in my system. You can download it from internet. It is for free of cost, and you can see it has couple of drive names. We can use any one drive name, and the entire disk can be encrypted using this TrueCrypt tool. But in my case, I am not going to encrypt the entire disk. Rather, I am going to create a small container which can hold the encrypted data. So I'm just going to create a new volume. So I'm just clicking on create new volume, and since I want to create a simple encrypted file container but not the entire drive to be encrypted, so I have selected the first option. Click next, and I'm just going to create a standard TrueCrypt volume, and then I'm just going to select a file of my container, and this particular file should not exist, so that I'm just going to create a new file. On my desktop, I'm opening a simple true directory. In that, I'm just going to create a new container, and I have named it as crypted. Let us say encrypted. So I'm saving it and click on next. It is asking me which encryption algorithm do you want to use. I just want to keep the default ones, which is encryption algorithm is AES and hash algorithm is RIP EMD160, and I'm just clicking on next, and it is asking me the volume size. I just want 1 MB, and this is the time you need to select a password. I have selected one password, and if you click, it is asking if the password is more than 20, it would be fine, otherwise it will be less secure. I just want to continue, so I'm just clicking on S. Now you have to move your mouse over here for a couple of seconds so that it will create a random pool. So I'm just clicking on format, and it is saying the TrueCrypt volume has been successfully created, and this is just one step. Now other step is we need to create one more important thing. We have to mount it. Now we have to mount the TrueCrypt volume. Let us say I want to create it with drive S, any drive you want. You can select any one drive name you want, and you can just click on, you can select the file you have created here, which is on my desktop, true and encrypted, and this is the one I have to give, and I just have to mount this. So I'm just clicking on mount, and now it is asking me a password which I have previously set up. Just clicking on OK. Now if you go to your my computer, a new drive with the name S would be created, and you can see. So now whatever the files you keep in this particular S will be encrypted and no one will be able to read them. I'll just show you how we can do that. I'm just going to create a new text document, which is secure.txt, and in this I'm just going to put some data. This is highly confidential. So I'm saving it. Now I'm just closing it, and again I'm going back to my TrueCrypt. Now I have to dismount it. So it has been removed. Now what I'm going to do is I'll just go to my desktop and I'll try to find out this file. Now I have only this encrypted file, and if you try to open it with some program, no program will be able to open it, and if a person tries to open this particular file, he will not be able to read it. I'll show you an example with Notepad. See, it is opening. And it cannot do anything. Oh, system got stuck. I'm just closing the Notepad because we cannot read it. Now this particular confidential file can be read only with the TrueCrypt again. No one else can read that. Even if you have this TrueCrypt, you need to have the password you have set up. If you forget your password, this file is gone. No other program can retrieve the information you have saved using your TrueCrypt. So I'm just now going to open this using, now I want to see the message which I saved. So I'm just opening my desktop, and true encrypted. Now I just want to, I have created my volume. I have created a container on drive S. This time I can open it with MNO, any drive I wanted. It doesn't need to be S. So I'm just going to open it with O, and now it is asking me a password. So I have to enter my password. So I entered. Now if I want to read the message, you can simply give a double click and see. And this is how we can secure our we can encrypt our information on a system using TrueCrypt. And this is very handy. It's a very beautiful tool we can use, and we can go through different options. We can encrypt the entire disk, and we can do a lot of things with this. So I'm just dismounting it, and I'm just closing my TrueCrypt, and let me go back to my presentation. Let us now try to understand what is hashing. Hashing is a technique where we take the original data and give it to a hash function and produce a hash out of it. And the process of hashing is irreversible. It means once if we generate a hash out of original data, using the hash we have generated, we cannot get back the original data using the same hash function or any other function. And in this figure we have a hash function which is taking original data as an input and is generating hash out of this original data. Now we have three hash properties which are very important. The first one is collision resistance. If you take a message M1 and if we have another message M2, any hash function, if we generate M1 hash M1 and if we generate another hash out of this original message M2, these two messages should not be the same. And another one is pre-image resistance. If we have a hash function and it has generated an output Y, and computationally it should not be feasible to find out another input which generates the same output using the same function. This is pre-image resistance. And the one last property called second pre-image resistance, which is very similar to our collision resistance. If you have message M1 and if you have generated a hash using some algorithm, there should be no other message M2 such that it hashes to the same output H. Now let us try to understand how we can generate a MD5 hash using a simple PHP script. First of all, MD5 is a hashing algorithm which takes a clear text string and generates a 32-bit hexadecimal number, and this particular 32 hexadecimal number is hash. Now in a PHP script we have a very simple PHP programming language, we have a very simple function called MD5 off. This MD5 off function takes a clear text string and it converts it into a hash. Let us try to understand how we can do that. I have already created a function. I have already created a simple script which generates hashes using MD5 off function in PHP. Now I'm just going to enter admin and it has generated a very simple hash. Now this is not so secure. I'll just show you one simple demonstration why it is not so secure. As we know, MD5, we have used MD5 hashing algorithm, and as we know, hashing algorithms are irreversible. Hashes are irreversible. So if you go to Google and if you type the same hash which we got and press enter, and we can clearly see it is saying this is the hash generated out of admin, and this is not so secured. It means if a hashing algorithm is used in a clear way without using any salt, it can be cracked using some rainbow table techniques. So this time what I'm going to do is I'm just going to add some hash. I'm going to add some salt to this particular hash, and I'm going to generate a different hash to the same admin. I have already written this script which takes input and generates a hash using a salt. Now the same admin string is taken and this time I'm just going to paste it in Google and see no results found. Though it is a simple, very simple string admin, though we are using MD5, since we have used a salt, it will not be cracked. And if an attacker comes to know that which kind of salt we have used, again it is insecure. So we have to keep the salt securely, we have to save it in a secure manner. And we recommend SHA-2 with a better salt to store your passwords in your databases. And now let us try to see a very simple demonstration using a tool called Hashcat. Hashcat is a very great tool which is available in couple of formats, and I am going to use the free version which is available for Windows, and it is also available in Backtrack, which is already installed. In Windows I have installed it in my system, and this is my Hashcat application. I have already installed it, and now I am going to use it using my command prompt. It's a command line tool and it is available as a GUI as well, and I am using command line tool, and I'm just copying this for to access my path where I have my Hashcat tool. So now I am in this directory, and I have a file which contains hashes. I don't know what is the clear text of these hashes. Now I am going to use the tool Hashcat to decrypt. We cannot say decrypt because there is no such decryption with hashes. So I am just going to use a rainbow table where I have used one more file called dictionary file. It contains a lot of clear text passwords, and it will check these clear text inputs with these particular hashes. It will, and if anything is matching, it will give it. This is a simple rainbow table attack. So what I'm going to do is I'm just going to run my Hashcat tool, Hashcat hyphen CLI 32 for my Windows. It's an exe file, and I have to give my hash.txt where my hashes have to be cracked, and I am just going to give dict.txt, which is the dictionary file. This dictionary file consists of clear text passwords, and this particular thing hash.txt consists of hashes. So it will automatically try to generate hashes out of this particular dictionary file, and it will try to check with this hashes in hash.txt, and if anything is matching, it will try to find out, it will try to display that these are the hashes we found, and press enter, and awesome, see, it got hash for admin, password, Scott, and p@ssw0rd, and these are the 4 hashes it found. And this is how Hashcat tool works in a very simple way. It has lots and lots of features to explore, and I'm just leaving that job to you. So let me go back to the presentation, and this particular demonstration is just to give you some insight of how we can use this Hashcat, and this is very simple demonstration, very basic demonstration. We can explore the other options that are available in Hashcat on your own. So I'm just going back to my presentation, and that's all with this cryptography video. Thanks a lot.